In each part, construct a polynomial function with the indicated characteristics. For part A, we want to construct a polynomial function that crosses the x-axis at least 3 times. To get started, we might sketch a possible graph. I've sketched the graph of a polynomial that crosses the x-axis at C1, C2, and C3. It crosses the x-axis at least 3 times. You might have drawn one that crossed it 4 times, or 5 times, or 6 times. I'm trying to make things as easy as possible, so I use the minimum number of times. It crosses at least 3 times. Now what we need to do is to make a connection between the x-intercepts of the graph and the equation for the polynomial function. What we need to recall is that if f of x is a polynomial function and the graph of the polynomial function has an x-intercept k, then a factor of the polynomial is x minus k. I've named my polynomial function p, so we can write the equation as follows. We write p of x is equal to, and then we start to write the factors of the polynomial. Since c1 is one x-intercept, then that means that x minus c1 will be a factor of the polynomial. Since c2 is an x-intercept, that means that x minus c2 will be another factor of the polynomial. c3 is also an x-intercept, so x minus c3 will be a third factor of the polynomial. When we multiply the leading coefficient by any remaining factors of the polynomial, we end up with another polynomial factor that I'm going to denote by q of x. This gives us the general form of the polynomial that we're looking for. To create a specific example, we just need to pick particular values for c1, c2, and c3. Suppose we pick c1 to be -2, c2 to be 0, and c3 to be 3. We substitute these values into our polynomial, and we get p of x is equal to x minus -2 times the factor x minus 0 times the factor x minus 3, and then we can multiply that by any polynomial that we would like. The simplest one that I can think of is q of x is equal to 1. So I'm just going to multiply by 1. When we simplify and rearrange the factors, we get p of x is equal to x times x plus 2 times x minus 3. Let's use our calculator to sketch a graph of this function just to make sure that it satisfies the given criteria. We enter x times x plus 2 times x minus 3. We then create a good viewing window using zoom. I'm going to select zoom standard number 6. And notice that we end up with a polynomial function. And the key thing is that it crosses the x-axis at least 3 times. Specifically, it crosses the x-axis at -2, at 0, and at 3. For part B, we want to construct a polynomial function that crosses the x-axis at -1, 3, and 10. So we can use exactly the same strategy that we used for part A. We'll just let c1 be equal to -1, c2 be equal to 3, and c3 be equal to 10. We get p of x is equal to the factor x minus -1 times the factor x minus 3 times the factor x minus 10 times any non-zero polynomial that we like. I've selected 1. When we simplify, we get p of x is equal to x plus 1 times x minus 3 times x minus 10. For part C, we want to construct a polynomial function that has a y-intercept of 4 and degree of 3. It doesn't mention anything at all about x-intercept, so rather than writing the polynomial in factored form, we can write it in standard form. We recall that a polynomial function of degree n can be written as f of x is equal to a sub n x to the n plus dot 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 plus a sub 2 x squared plus a sub 1 x plus a sub 0. The value of n is a non-negative integer, and it's called the degree of the polynomial. The value of a sub 0 is the y-intercept. That's because if we replace each x with 0, each term containing an x becomes 0, and we're just left with a sub 0. So a sub 0 is the y-intercept. For part C, we're to construct a polynomial function that has a y-intercept of 4 and a degree of 3. Therefore, we need to make sure that we choose n is equal to 3 and a sub 0 is equal to 4. We can choose the other coefficients in pretty much any way that we would like. To make things as simple as possible, I'm going to select a sub 1, a sub 2, and so on to be 0, and a sub 1, that can't be 0, so I'm going to choose that to be 1. The resulting polynomial is p of x is equal to x cubed plus 4. Now keep in mind, answers will vary, so as long as 3 is the highest power of x and your a sub 0 is 4, then your answer is probably correct. We can use our calculator to check our answer. First of all, we go to y equals to enter x cubed plus 4. We create a good viewing window. I'm going to go to Zoom and select 6, Zoom Standard. And the key thing that we observe is that we end up with a graph that has a y-intercept at 0, 4. We can see that clearly if we use trace. When x is equal to 0, the y value is 4, and the graph passes through the point 0, 4. For part D, we're given essentially the same scenario, but this time we want to construct a polynomial function that has a y-intercept of negative 4 and a degree of 5. So we'll want to make sure that we choose a sub 0 to be negative 4 and n to be 5. One example is p of x equals x to the 5th plus negative 4, which can be written more simply as p of x is equal to x to the 5th minus 4.